Hi guys, it's Miss Singh here. If you still need some help with figuring out how to balance an equation, this is what I'm here to talk to you about. A couple days ago I gave you, I guess it was the end of last week, I gave you a worksheet where you had to count up the number of elements in a compound or a molecule and determine, all the different elements that are present in that molecule. So this is the sheet we did on Monday, the 27th. I told you to skip part A and part B. Those of you who might need some help probably need to do part A and part B. If you're not understanding how to balance, you just might need to figure out how many elements are present in the first place. So part A says identify the following parts of each chemical formula by circling the subscripts and drawing a square around the coefficient. So and I'm using this little pad here, so this is this H2, this is a subscript. So what that means is that we have an H bonded with an H. That's a dihydrogen molecule, okay? So that's two hydrogens that are present. That's what that subscript means. Now, this 2 here, this is a coefficient, that's a square. What this means is that we have an HCl, and then we have another HCl. So a hydrogen bonded with a chlorine. It's a covalent bond. So we have 2 separate molecules. That's what a coefficient means. We have a total of 2 hydrogens and 2 chlorines. They're not bonded with one another. The hydrogen's bonded with this chlorine, this hydrogen's bonded with this chlorine, but that's what it means. Okay? This is a coefficient, the 4, and this is a subscript 2. So what this means, I'm going to draw it over here, is we have an O2. That's a molecule, an O2, another molecule, an O2, another molecule, an O2. So we have a total of 4 O2 molecules, or a total of 8 oxygens. 4 times O2 is 8. CH4, this is one of those ones where it was the C and then you had an H, an H, an H, and H on either side of it. So 1 carbon, 4 hydrogens. We have 3 CO3, so this is our, and I should have put a circle around that, that's your subscript. This is your coefficient, and this is your subscript. So what that one's telling us is that, I'm going to draw it down here, we have a CO3, so let's see, carbon had 4, so we have 3 oxygen, so let's do 1, 2, 3. There we go. But we have 3 of those, so there's another carbon over here with 3 oxygens, and another carbon over here with 3 oxygens. So that's the difference between a coefficient and a subscript. A subscript is how many atoms of that element in the compound. The coefficient is how many of those compounds are we dealing with. 2 NaOHs just means we have an Na with an O and an H, and then we have another Na with an O and an H. So we have 1 H, 1 Na, 1 O, but 2 of them all together. All right. So part B lists the symbols for the atoms in each formula. So in this one we have carbon and we have hydrogen. We're starting with 2 and we're starting with 6. Here we have a magnesium and an oxygen. So we have 1 magnesium oxide molecule, but we have 2 of the molecule. So 2 Mgs total, 2 oxygens total. We have 4 P4O10s. So we have P and we have O. 4 times 4 is 16 P's. 4 times 10 is 40 O's. That's huge. We have an N and H, and we only have 1 N, 3 H's. We have 3 AlOH3. So that means we have an Al, we have an O, and we have an H. Okay? It's showing us that we have 3 OHs, so that means we have at least 3 oxygens and 3 hydrogens, but we have 3 AlOH3s. So 3 times Al is 3, 3 times O is 3, but this is an OH3, so it's 3, there's 3 oxygens times 3, so 3 times 3 is 9, and then same thing with the hydrogen, 9. So we have So let me erase some of this and draw that out for you if you're not understanding. Let me get a big old eraser on here. Clean all this up. So what this molecule is showing us is we have an Al, and then an OH, an OH, and an OH. Okay, that's what AlOH3 is. But how many of those do we have? It says we have 3. So OH, 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 and another Al with an OH, an OH, and an OH. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. Whoops, I missed this one. 1, 2, 3, 4, 5, 6, 7, 8, 9 oxygens, and then 3 aluminums is what they're showing us. Here we have 2 times H2, so we have H4 and then O4, because 2 times H2 is 4 and 2 times O2. So an H2O2. So it's telling us we have 2 H2O2s. So 1, 2, 3, 4, 1, 2, 3, 4 overall. Okay, let's go over to the back side. Alrighty, I'm gonna make this a little bit bigger. Let's practice. So one of the things I was seeing today in class is that people are listing their elements, which is good, but you need to do them in the same order on your reactant side as you do on your product side. So over here I'm going to put a Cl, I'm going to put an Na, and I'm going to do a Br, just because that's the order they are. Over here I'm going to do the same order, Cl, Na, Br. Not the order that they have over here, but I want to make sure I'm comparing them across. If I put in a Br here and an Na here, visually I'm not going to be able to compare them that well. So on my reactant side it says I'm starting with 2 chlorines, 1 sodium, 1 bromine. Over here I'm starting with 1 chlorine, see it's Cl, 1 Na, and 2 bromines. Alright, so it looks like I need to balance my chlorine and I need to balance my bromine. Okay, so I'm going to start with my chlorine. In order to do that, I can't put a 2 here. One of the rules is you can't add a subscript, and you can't put anything in the middle of a compound, but you can add a coefficient to the front. So what that's telling me is instead of just 1 sodium chloride, now I have 2 sodium chlorides. So basically I'm taking it from an NaCl to another NaCl. So now I have 2 of them. So how many sodiums do I have? I started with 1, now I have 2. How many chlorines do I have? 2. So 2 times Na is 2, 2 times Cl is 2. So my chlorines are balanced, but what have I done to my sodium? I've unbalanced it. So now I've got to come over here and get myself up to 2 sodium. So again, you can't add a subscript, you can only put a coefficient. So instead of 1 sodium bromide, now we're going to have 2. 2 times Na gives me 2. 2 times Br gives me 2. So now this is a balanced formula. I have a chlorine, diatomic chlorine, plus 2 sodium bromides is going to make 2 sodium chlorides and 1 bromine gas. Okay? Alright, let's list them over here. So we have an H and an N on my reactant side, and I'm going to put them in the same order, H and N on my product side. It looks like I have 2 hydrogens, 2 nitrogens to start. I have 3 hydrogens and only 1 nitrogen to start. So I need to start balancing. So if I have 2 over here, let's go ahead and get 2 nitrogens. So 2 times NH3, that's going to get 2 times N gives me 2. Yay, my nitrogens are balanced. 2 times H3 is going to give me 6. Okay, because 2 times 3 is 6. Basically what I'm doing here is I'm saying I have an NH3, but I'm doing it twice now, NH3. So that's a total of 3 plus 3 is 6, and an N is 2. So my nitrogens are balanced, but my hydrogens are not. So what times H2 will give me 6? 3. So basically I'm starting with an H2, and now I've got 3 of them. Okay? So a total of 2, 4, 6. Got it? Alright, over here, Na, I only have 1. Br, I have 2. And I'm going to make an Na and a Br. And it looks like I have 1 and 1. So my bromines are not balanced. So I'm going to put a 2 in front of it. 2 times Na gives me 2. 2 times Br gives me 2. So my bromines are good, but what did I do to my sodium? I messed them up. So all I have to do is put a 2 in front of the Na, 2 times Na, that's That's going to take me up to 2. So 2 sodiums plus a bromine, a diatomic bromine, is going to make 2 sodium bromides. Next one, this is a little bit bigger, so I'm going to list my elements again, same order on both sides. So copper, chlorine, hydrogen, and sulfur. Okay, same order. Chlorine or copper, I only have 1. Chlorine, I have 2. Hydrogen, I have 2. Sulfur, I have 1. Copper, I have 1. Chlorine, I have 1. Hydrogen, 1. Sulfur, 1. So the only thing I really need to balance here is my chlorines and my hydrogens. So if I have 2 over here, that means I need to get up to 2 here. So if I put a 2 in front of my hydrochloric acid, 2 times H is 2. 2 times Cl is 2. And I balanced. Next up, mercury oxide. Sorry, let me get my pen going. So I'm going to list my elements, MHG. I have an oxygen and a chlorine. Alright, so over here I have 1 mercury, 1 oxygen, 2 chlorine on my reactant side, 1 mercury, 2 oxygens, 1 chlorine on my product side. So my mercuries are good, my oxygens and my chlorines are not. So let's see, what we could do is put a, I'm going to go ahead and do my oxygen. 2 in front of the HGO, 2 times Hg gives me 2, 2 times O gives me 2, so my oxygens are good, but my chlorine's still messed up, and now I've screwed up my hydrogen. Convenient. If I put a 2 over here, that'll fix my mercury, and it'll fix my chlorine, because 2 times Hg is 2, 2 times Cl is 2. So it's 2 mercury oxides plus a chlorine, diatomic chlorine, is making 2 mercury chlorides plus an oxygen molecule. Okay? Carbon, hydrogen. Carbon, hydrogen. I have 4 and 1 over here. 1 and 2. Okay? So my carbons are good. I don't really want to mess with this side, but I do need to get my hydrogens up. So 2 times H2 is 4. Okay? Challenge problem. It's not much of a challenge, though. So we have carbon, we have hydrogen and oxygen. Carbon, hydrogen, oxygen. Again, make sure you write them in the same order on both sides. So let's see, I have 2 carbons over here. I have 6 hydrogens and 2 oxygens. Looks like I have 1 carbon, 2 hydrogens, and I've got to add up my oxygens. I have 2 plus 1 is 3. Okay. So if I have 2 over here, let's go ahead and put a 2 in front of this one to balance my carbons. 2 times C is 2. 2 times O2 is 4, plus 1 takes me up to 5. Look. Let's go ahead and fix my H. So I got my carbons good. My oxygens are really messed up now, but maybe they'll fix themselves in a minute. I have 6 over here and I only have 2. So what can I put in front of this? 3. 3 times H2 is going to take me to 6. Yay, that's balanced. 3 times O is 3, plus the 2 times O2, so 4. So 3 times, that's O3 plus an O4 is going to take me up to 7. Or even worse. Okay, so probably not looking so great here. Let's try something else. Let's try to get to, what's another multiple we could deal with? Let me erase all of this and try something else. Come on, eraser, catch up. Ooh, I shouldn't have erased all of it. Let's list them again. We have C, we have H, we have O, 2, 6, 2, CHO, 1, 3, 2. Okay, let's try, And one of the rules is don't ever try and balance something it's in two different, so we shouldn't focus on the oxygen first, really, is one of the rules. We should focus on one of the others. So let's go ahead and get this up to 3. We failed at carbon, going carbon first. So let's try hydrogen first. So that gets us up to 6, and then 3, so that takes us up to 5. And we haven't dealt with our carbons yet, so let's try to get ourselves to, I hate to mess with our hydrogens, but I think we're going to have to. Let's go ahead and do, let's go ahead and do our carbons now. So 2 times 2 is 4, and 2 times H6 is 12. So that screwed that up. So what can we do over here? Let's do a 6. 6 times H2 is 12. 6 oxygens plus 2 oxygens is going to give us 8. Let's see. Now, so you see it's 6, and then plus 2 is 8. Okay. Let's balance our well, we have this oxygen over here, so, we need to balance this carbon. So what can we put in front of it? We put a 4. 4 times C is going to give us 4. But 4 times O2 is 8, plus 6 is 14. Okay. So what can we put in front of this to get ourselves 14? A 7. And that should be it. Looks like we're balanced. We had to play around with it. We didn't do it right the first time, but we did eventually get it right. Okay. Now the other thing that we did today was classifying chemical reactions. Somebody asked me a question, what does single mean? Well, single is just single replacement. I was just getting lazy and didn't write the whole thing. But if you start with one thing and break it down, it's decomp. If they kind of switch partners, that's double replacement. If somebody's always left out in the end, that's always a single replacement. If 2 smaller things are coming together to make something larger, that's a synthesis reaction. Okay. And then saw some people were struggling with this. It's simple mathematics. You're just trying to solve for x, basically. So, I'm just going to look at this number 3. If we have 350 grams of something plus something else, how much do we need here in order to get ourselves to 500? So you just subtract them. And on this one, we started with 80 grams total over here, so we need to have 80 grams over here. 64 plus 16 is 80. So what plus 44 is going to get us to 80, and that was 36. Alrighty, so that's some balancing equations. You need to do 1 through 7 on the balancing equation worksheet, because it would just require too much work to do all 15 of them. So just do 1 through 7, and that should be it. Bye.